Okay, so I made up some questions to do with you guys, and then hopefully that should help you for your examples that you guys have. Thanks again for your patience. Okay, so we're going to do this one. This one's a solving one. Again, let me know if it's unclear. Just go in the chat and let me know. So we have 9 over w minus 3 minus 4 over w minus 6 equals 18 over w squared minus 9w plus 18. Can you guys see that clearly? Just gonna stop. Okay, so what you always want to do when you're solving is you want to get common denominators. So you need to factor all the denominators first. Okay, so this one you can't factor, which is w minus 3. W minus 6 can't factor, so you leave it as it is. But this one you can factor. Okay, so step 1 is factor. Okay, so you want to find two numbers that multiply to 18 and add up to the middle, which is negative 9w. So you're going to have to, if there's a number in front of w squared, you're going to either have to do box method or you can do that fraction method, decomposition. So whatever you know how to, however you know how to factor, that's what you want to do if there's a value in front of your x squared or w squared. So in this one, I have two numbers that multiply to 18 and add up to negative 9 would be w, let's see, I have 6 and 3, minus 6 and w minus 3. A little hint, guys, is look at the other numbers. That kind of gives you a hint of what the numbers will look like because they should be similar to the other fractions. Okay, how's it going so far? Are you guys seeing me properly or is there any issues with understanding? Okay, so go to the chat and just tell me if everything's okay so far. Perfect. Thank you guys. Okay, so once I have the denominators factored, you want to make sure every fraction has the exact same denominators. So this first fraction is missing the w minus 6. Okay, so I'll do that with a darker color actually. So w minus 6 is missing for the first fraction. What I do to the bottom of the fraction, do to the top. Second fraction is missing w minus 3. What you do to the bottom, do to the top. This last fraction has both of those factors in the denominator, so you do not have to do anything to the 18. So that one's all good. And then what you're really doing is you're multiplying the entire equation by that common denominator. So our common denominator is w minus 6, w minus 3. And if you do that, that crosses off every single denominator as long as they're all the same. Okay, so by multiplying the top by w minus 6, w minus 3 to everything, you're crossing off all the denominators. Okay, so the denominators are all gone now, which is awesome. Less work for you. So now what you're left with is just the numerator, the top. W minus 6 times 9 minus 4 times w minus 3 equals 18. So pretty much once you get that common denominator, cross off the denominators. They're gone. You don't have to work with them anymore. Now you're going to distribute any values into the brackets. So if you have two brackets, you're going to have to do FOIL. Here, you just have to distribute because your goal is to get rid of the brackets and then you want to simplify your variables. So you're going to have 9w minus 54 minus 4w plus 12. So make sure you distribute this negative as well. So that's really important. A lot of people forget to distribute that negative value. Okay, so if there's a negative in front of the brackets, you always have to make sure it goes to everything. So anything followed by subtraction, distribute. And so that's equal to 18. Now, if you have something like w squared, you're going to get a quadratic equation. You're going to bring it all to one side, making it equal to 0. So I'm just saying, for example, let's say you had like this was squared. I'm going to take it off afterwards. But what you would do is bring everything to make one side equal to 0. And then you're going to use the quadratic unit to solve for it. You can do it graphically. You can do it using the quadratic equation, or you can factor possibly. So that's if you had w squared. In this case, we don't have any squared, so it's just about getting the w's by themselves. So these guys can go together. 9w minus 4w is 5w. And then you're going to bring the negative 54 and the positive 12 to the other side. So that's going to be 18 plus 54, because you're changing the signs, minus 12. Okay, so 18 plus 54 minus 12 gives you 60. So 5w equals 60, and then you're going to divide both sides by the value in front of w. So 60 divided by 5 is 12. When you get your solutions, you always need to check your solutions, okay? So I just want to show you a quick little kind of thing that you can do as well in your calculator. So I'm going to show you guys this. I'm going to punch it in and I'll show you what I did. Okay, so what I'm doing here, guys, is I'm punching in the left side of the equation, the original question, into the y1. And then you're putting the original right side of the equation, which mine was 18 divided by bracket. So I'm going 18 divided by bracket, x squared. So it's just x squared minus 9x plus 18. So this is the graphical way of solving for a rational equation. So you put the left side of your equation into y1, the right side of your equation into y2. Then you need to adjust your graph to be able to see the intersection. So I'm going to use the standard graph for now, like the standard window, the negative 10, positive 10, negative 10 window. So I'll show you that. So this is the window I'm using. Okay, and then you graph it. So it gives you like this crazy image. But what you're trying to do is you're trying to find the intersection between the left side and the right side. And because we know that they're equal, the left side should be always equal to the right side, we want to see where they intersect with each other. Okay, so I know, guys, just from this, that the intersection should be at 12. So usually I have my window, the standard window, negative 10, positive 10, but I'm going to have to make sure I see 12. So x of 12 is not visible, so I'm going to go up to 15 then, just a slightly higher value. Okay, so I graph it again. So my intersection should be about here. So then you go second trace number 5. That's intersection. You move your cursor until you get as close as possible to that intersection. So I'm moving my graphing calculator cursor until I'm around where I think the intersection is. And then all you do is you press enter 3 times. Enter, enter, enter. And if you guys look, there's my answer. My answer is 12, x equals 12. So this is how you can check your answer, is you can do it graphically. So what I did was I put y1 equals the left side of my equation, which was this. The right side of my equation was 18 over. Now, when you put this into your calculator, you're going to have brackets around any time there's more than one item in your denominator or numerator. You need to keep them together. And so 18 doesn't need brackets, but the bottom does. like that. Okay, so you put brackets, and then what you're doing is once you graph it, you figure out your window, and then you're pressing second trace number 5. And then you're going to press enter 3 times to get the intersection. So this is my steps to be able to check graphically and to see if you got the right answer. So you do need to know, you do need to be able to do both. This is the algebraic way where you're doing it like the long way, and this is the graphical solution. Okay, so that's how you can solve it. But I think I said in your assignment that I wanted algebraically, but you can always check that you got the right answer using this method. Okay. So any questions about this one? So just to recap, I factor all the denominators, get common denominators, cross them off. Then you work with the tops by distributing and getting your variables, your common variables together. So that's just arranging and joining together like terms. Then if it's quadratic, you'll get everything to one side equaling 0. And then you would factor it or do quadratic equation or graphically solve for the solution. But in this case, I only had W, so I only had to solve for W by isolation. Then you want to check your answer. Okay, so let me know in the chat if you have any questions about this one, if you want me to explain something a little bit more, or if you're okay, just say good, or give me a check mark or something. Give me a thumbs up, or just say okay before I move on to the next one. You guys still there? Okay, okay, good, perfect. Good, good, okay, awesome. Okay, so I'm gonna erase this, guys, but since I'm recording this, I will post this later on, and you can always look back and pause the video at a certain point if you need to see it a little bit closer. Okay, so let's go on to question number 5. This one's similar to question number 5 that you guys have in your assignment. So I tried to pick one that was similar, okay? So in my question, I'm going to write down the details, but I will put this question, let me go back. I'll show you this, guys. I'll show you it while I'm reading it to you. And then again, you can go back and kind of pause it to read through this question. So Ted is a long-distance driver. It took him 30 minutes longer to drive 275 kilometers on the Trans-Canada Highway, west of him to drive 30 kilometers east of Swift Current. He averages 10 kilometers per hour less while traveling west of Swift Current due to more severe snow conditions. What was Ted's average speed for each part of the journey? So I'll just show you guys that. That is the question I'm doing. Okay. So what you guys want to start with is you want to start with a chart. In this case, the chart's going to have distance, speed, and time. So I'm going to work on creating the equation first, and then we'll go back and we'll solve the equation afterwards. So we have, it took him 30 minutes longer to drive 275 kilometers on the Trans-Canada Highway west. So here we're going west. So I'm going to divide my chart into 2 sections. We have west, and then we're going east as well. So those are my 2 divisions of my chart. So the distance he's traveling west is 275 kilometers. So just make sure your distances are the same. And then it took him 300 kilometers east of Swift Current. So he drove 300 kilometers in this direction. Now, always read the question after that. What was Ted's average speed for each part of the trip? X will represent his average speed for each part of the trip. So you need to always make sure your X is going to help you find your solution. So make your X, if X represents speed, make X your speed. Okay, so we're going to have X in this column of our diagram. Okay, so what it says is he averaged 10 kilometers per hour less while traveling west of Swift Current due to more severe snow conditions. Okay, so he averaged going west 10 kilometers per hour less when he's going west. Okay, so as you can see, X, we're subtracting 10 kilometers per hour. So speed will be in kilometers per hour. And then here, east, we have no information about that, so we're going to set that to X. So as you can see, when we're comparing east to west, we know that west, he's going 10 kilometers per hour slower in that case. To get time, it's always going to be distance divided by speed. So you're going to take your numbers, you're going to take 275 and divide it by your speed here. So 275, you're going to divide by, in brackets, X minus 10. And then your second one, you're going to take your distance for east, 300 kilometers, and you're going to divide that by X. Okay, so once you have these two numbers, the next information is they're going to give you some information about time. Here it tells us it took him 30 minutes longer to drive 275 kilometers. So we know that this guy is going to take longer. Okay, so we're going to put that, a little kind of information right here. So you need to figure out which one is going to take more time. Because he's driving slower, we know that that one's going to take longer. The reason we need that information is the longer one, the one that's going to take more time has to be the first fraction. So 275 over X minus 10 needs to come first, because there's a time difference between these. This time is going to take 30 minutes longer than this time. So we're going to subtract the 2 times. Okay, so we're taking 275 over X minus 10 this time here, and we're subtracting this time, and that's going to give us time as well. But there's an issue here. 30 minutes is not what should go here. The reason being, this is in minutes, but our speed is in kilometers per hour. You need to make sure the units all make sense, that they all correlate to each other. So if this is in kilometers per hour, we need to convert 30 minutes to hours. Okay, so what you're going to do is you're going to divide that number by 60. Okay, so we know that this is going to be just a half, but 30 divided by 60 we know is 0.5 as well. So we're going to put 0.5 as the time difference between the two fractions. Okay, so make sure if you see minutes, convert it into hours for it to make sense. So this is our equation that we need to create to be able to solve for this. So that's how we create these equations, by creating this chart. Okay, and then you're either going to add these two fractions or subtract them. You always subtract if they give you a time difference. You would add them if they gave you the total time the trip took. Okay, good so far? So what I'll do is I'll erase this chart right now, and then we're going to solve this equation here. Okay, so I'm going to keep the equation. We're going to solve for the actual answer. Now you can do this one graphically if you wanted to. Remember, the left side of your equation would be y1, the 0.5 would be your y2, and you'd be finding the intersection between them. So if you can find the intersection, now you got to watch, because sometimes there could be two intersections. So you might have to extend your window, because in the end, you have to make sure your answer makes sense. If you tell me that the truck is going like 5 kilometers per hour, I probably won't believe you, right? Or if you're telling me that the truck's going, 1,000 kilometers per hour, again, not logical. These answers, the one that you're going to get in your assignment, will make sense. It's very logical answers for like what a car or a truck is driving. Okay, so if you want to do this one algebraically, common denominators first. Okay, so with this fraction, I need to multiply this first fraction by x. X to the bottom, x to the top, because these are different factors. X minus 10 is different than x by itself. This one's missing the x minus 10, top and bottom. This guy is missing the x and the x minus 10 because it has nothing in your denominator. What you do to the bottom, do to the top. And because they're all the same denominators now, I can save myself a lot of time by just crossing them all off. Okay, so cross off your common denominators, and now you're just left with 275x minus, you're going to have to distribute this minus 300 into the brackets. So minus 300x and then minus 300 times negative 10 will become positive 3,000. And that's equal to, we're going to have to distribute this as well. So you're going to have to take this 0.5x and distribute it into x minus 10. So it's going to be 0.5x squared if you distribute. And then you're going to have to distribute 0.5x into negative 10, giving you negative 5x. So be very careful how you distribute it. You can do like these two guys together, put them together, and then distribute. So whatever helps you not miss anything there. Okay. Now, as you can see, I have this x squared value right there. So that means I'm going to have to bring everything to one side and make it equal to 0. So I'm going to bring everything to the right side because I always prefer for the a value to be positive. So I'm going to have 0 equals 0.5x squared. You're going to have minus 5x because these signs don't change since I'm keeping these on the right, but everything else will change. The signs on everything else are becoming the opposite sign. These guys can all go together. They're common, they're like terms. Negative 5 minus 275 plus 300 gives you 20. And then, like I said, you guys have choices here. You can choose to actually factor this if you want to find the answers. I kind of prefer the quadratic equation. So remember, this is your A value, this is your B value, and this is your C value. Okay, so it's going to be x equals negative b plus minus square root of 20 squared, which is b squared, minus 4ac. Make sure you include the signs. Divide that whole thing by 2 times your a value. Okay, so I'm going to put that in my calculator. I'm going to put my radicand in first. Okay, so I get this radicand is equal to 6,400, and then I square root that. It's actually going to be a nice answer there, and it's going to be 80. So I have x is equal to negative 20 plus minus 80 over 2 times 0.5 is 1. So I don't have to write that. So all you have to do, just going to move that, is calculate what negative 20 minus 80 is. So that's going to be negative 100. And x equals negative 20 plus 80. So that's going to be my answer right there, because a negative distance or a negative speed doesn't make sense here. So the only answer that makes sense is going negative 20 plus 80, which is 60. So that would be my speed. And I believe that was the speed going east. So x was, this is the speed going east, kilometers per hour. And then to find the speed going west, we have to subtract 10 to this value right here. So we would subtract 10 from this answer right there, and we would get that 50 kilometers per hour is the speed going west. So those are my two solutions there. because they wanted the speed for each part of the trip, the west and the east. Okay. So this kind of shows you what would happen if you have a quadratic equation ending up from your rational equation. Okay. So if you create your chart, guys, and you're struggling coming up with the equation from it, you can always send me your chart and we can look at your chart and see what's going wrong and try to fix it from there. Just make sure your answer is making sense, okay? If you're doing it graphically, don't forget to graph it and just make sure you extend your window for logical values. Now closing the window. Guys, any questions about this one here? Everybody's good? Perfect. Okay, last example. This one, again, like I said, is important for next year, 30-1. So I'm going to erase this again. You can always go back once I post the video and look back at this example as you're doing the one in your notes or in your assignment. Okay, so our last one is they're giving us this equation. This is the reciprocal lesson, the 7.4 lesson. So this is similar to example 6 in your assignment. So imagine you have this equation. This is a quadratic, and they want the reciprocal of it. So the reciprocal is just going to be 1 over that number or that function. Okay, so it's going to be 1 over x squared minus 16. So what they want us to do is they want us to sketch what this looks like. And to really understand this and do this properly, you need to be able to sketch this without just putting it in your graphing calculator. So you need to understand what happens on the actual graph, okay? So first of all, they want us to find the intercepts, okay? So if I'm doing this, I'm going to solve for the x-intercept and then the y-intercept. The x-intercept is when you make y equal to 0, and then you solve for the x value. So for example, if the equation is this, I'm going to make y equal to 0. Okay, so whenever you have 0 on one side, you can multiply both sides by that x squared minus 16. So what I'm going to do is multiply that with that. And as you can see, that crosses itself off. There is going to be no x-intercept. The reason being, there is going to be something called a horizontal asymptote at your x-axis. So there's going to be like this dotted line right on the x-axis, which means your graph is going to get very close to this line, but it's not going to actually touch it. So there are no x-intercepts. Okay, so that's what you should take from that. Now, next year in 30-1, there will be x-intercepts because the graph will move up and down, left and right. But for this year, 20-1, you're going to have a horizontal asymptote, which is a line that the graph gets very close to but doesn't touch. Okay, it's going to occur right there at the value of y equals 0. Okay, the next one we want to find is the y-intercept. So the y-intercept, you set x equal to 0. So you go 0 squared minus 16. 0 squared is going to be 0, so that's gone. So y is going to be equal to 1 over negative 16. It's going to be a really small value, so 1 divided by negative 16 is like equal to negative 0.0625, okay? So I'll plot that, and I'm going to use blue for that. So on your y-axis, you're going to plot a really close value to that x-axis. I'm going to start labeling my graph here. 1. Okay, the next thing you guys need to find is you need to find the non-permissible values. So that's why I put this lesson in with this unit, because we need to find the non-permissible values of this. So we need to factor it. This is a difference of squares. So this is x minus 4, x plus 4, which means that the non-permissible value is x cannot equal 4 and x cannot equal negative 4. So if you make both of those factors equal to 0 and you solve for the x-intercepts of those, then you're finding the non-permissible values. So the reason that's important again is because these are called vertical asymptotes. So when it comes to graphing these equations, you're going to have a dotted line at positive 4. This is x equals positive 4. And you're also going to have another one at negative 4. So it's a dotted line again that you're not touching. So that's why I make it dotted. Okay. Now we're going to have to figure out what the graph is going to look like now. Okay. So our graph, when we have the original function, we know that this is an upwards facing parabola. So I like to sketch what that looks like, just so you can see where it comes from. So x squared minus 16, I'm going to graph that. And that gives me an image like this. I'm going to do it with green. So this is what the original function looked like before I did the reciprocal. What I want you guys to notice is that where the graph has x-intercepts, those become the vertical asymptotes. And also, if you flip the minimum value here, that's where it becomes that. So the minimum value is actually negative 16. If you flip negative 16, you get negative 1 over 16. So that's why that point's right there. The reason I need this picture is I need to make sure that my reciprocal graph is in the same regions as my green graph. So what you're going to notice is that at y equals 1 and y equals negative 1, you're going to have something called invariant points. So along this y equals 1 line, this point is going to be identical to the original point. Same thing here. At y equals 1, that's where it touches y equals 1. That's also going to be an invariant point, a point that's identical to your reciprocal and your original graph of x squared minus 16. Along y equals negative 1, that will also be an invariant point right here and then right there. The reason being is if you flip the y coordinate, it stays the same. If you go negative 1 over 1, it becomes still negative 1. It doesn't change. Okay. Now, once you have those plotted, now you're just going to draw through them. So you're always going to stay close to those horizontal asymptotes. You're going to touch that invariant point, and you're going to shoot straight up, again, staying close to that dotted vertical asymptote. You need always arrows on both sides of that kind of like L shape. Same thing on this other side. You're going to come and stay close to that horizontal asymptote. Right when you touch this invariant point, you're going to shoot up, and it's going to stay close to this dotted line, but it's not going to go through it. You need, again, arrows on each side. Okay. And the last part is we need kind of like if it's an upward facing parabola, it's going to become a downward facing kind of U-shaped parabola here. Okay. So what you're going to do is stay close to your vertical asymptote. You're going to go through that invariant point, through your new point that we said was the y-intercept value, and then again through that invariant point, and it's going to turn and go straight down. Make sure you have arrows on each side. Okay, so if you ever want to find out what these invariant points are, you just have to find the intersection of these two graphs. So where these two graphs intersect, that would be your final answer for the invariant points. So that's just something extra if you wanted to actually find that. You would do that graphically. Okay, and then you can check with your graphing calculator, guys. So I just want you guys doing this without and trying not to depend on what the image looks like, because your graphing calculator doesn't sometimes do a good job of drawing it, because like this is what my graphing calculator does. But it's not great. It doesn't really show you what the image is supposed to look like. Okay. If you're really kind of confused, meaning like you want to really see what this image looks like, go to Desmos and then you can check your answer using that. So if I go to Desmos and I graph 1 over x squared minus 6c, it does a way better job of graphing reciprocal functions. Okay, so as you can see, that's way better. If I like zoom out, it does look like what I've been trying to draw. Oops, go there. Okay, so there's the two L shapes on either end and that kind of like downwards parabola. But if you guys zoom in, you're going to see that it doesn't actually touch the x-axis. So it might look like it does, but it shouldn't. Okay. And then I'm just going to go to your assignment to see if I answered any questions there. Was there any other questions on there that's missing? Let's see. Okay, so look through your assignment, guys. Is there any question you still have about that? About this question, how to draw the reciprocal function? You're good? Perfect. Okay, guys. Don't forget that I'm still available tomorrow if you need help as well. So if you're struggling finishing up the assignment, you need one more example, I have no problem making another video. Just ask for it. Just say, hey, I need another example. I can definitely send you something else to help you and assist you completing that assignment. Okay, so thanks for being patient, guys. It's not the ideal. Like, hopefully you guys can see that clearly with the shakiness and all that stuff, but technology for you. So thank you so much for being patient, and I appreciate you guys joining me. So have a good one, guys. Enjoy your weekend, get your assignment done, hand it in, and then enjoy